Good morning to everyone. I am Latha. Today I am going to discuss about multi-dimensional data model. We know the multi-dimensional data. First, we know the dimensional data model. In today's world, data is crucial part of any organization. Many companies transform the data through an ETL. ETL means extract, transform and load. ETL process and store this data in a data warehouse for further analysis. In order to access the data from this data warehouse, companies use a process called dimensional data modeling. Dimensional data modeling is a data structure that helps optimize a data warehouse to retrieve data quickly. Components of dimensional data modeling. There are 5 components of any dimensional data model. They are given below. First one dimension, second one facts, third one attributes or measures, third one fact tables, and last fifth one dimension tables. First one dimension. Dimensions are the assortment of information that contain data around one or more business measurements. It may be topographical information, item data, contacts, and so on. Dimensions give the context to the fact creation. Second one, facts. Facts are the collection of measurements, metrics, transactions, etc. from different business processes. It typically contains business transactions and measure values. Third one, attributes or measures. Attributes are the elements of the dimension table. For example, in an account dimension, the attributes can be first name, last name, phone, etc. Fourth one, fact tables. Fact tables are utilized to store measures or transactions in the business. For example, in internet business, a fact can store the requested amount of items. Fact tables, as a rule, have huge rows and fewer columns. The fact tables are related to dimension tables with the keys known as foreign keys. Dimension tables. Dimension tables store the dimensions from the business and establish the context for the facts. They contain discrete data that is linked to the fact table. Dimension tables are usually optimized tables and hence contain large columns and fewer rows. For example, contact information can be viewed by name, address, and phone dimension. Product information can be viewed by product code, brand, color, etc. City, state, etc. can view store information. And next, what is multidimensional data model? A multidimensional model views data in the form of data cube. A data cube enables data to be modeled and viewed in multiple dimensions. It is defined by dimensions and facts. The dimensions are the perspectives or entities concerning which an organization keeps records. For example, a shop may create a sales data warehouse to keep records of the store's sales for the dimension time. Dimension time for the dimension, time, item and location. These dimensions allow the save to keep track of things, for example monthly sales of items and the locations at which the item was sold. Each dimension has a table related to it called dimensional table, which describes the dimension further. For example, a dimensional table for an item may contain the attributes item name, brand, and type. A multi-dimensional data model is organized around a central theme, for example, sales. This theme is represented by a fact table. Facts are numerical measures. The fact table contains the names of the facts or measures of the related dimensional tables. Schemas for multi-dimensional data model are: first one is star schema, second one is snowflake schema, and third one is fact constellation. The first one is star schema. The simplest data warehouse schema is star schema because its structure resembles a star. Star schema consists of data in the form of facts and dimensions. The fact table present in the center of star and points of the star are the dimension tables. In star schema, fact table contains a large amount of data with no redundancy. Each dimension table is joined with the fact table using a primary or foreign key. Second one, snowflake schema. The snowflake schema is a more complex than star schema because dimension tables of the snowflake are normalized. The snowflake schema is represented by centralized fact table, which is connected to multiple dimension table, and this dimension table can be normalized into additional dimension tables. The major difference between the snowflake and star schema models is that the dimension tables of the snowflake model are normalized to reduce redundancies. Third one, fact constellation schemas. A fact constellation can have multiple fact tables that share many dimension tables. This type of schema can be viewed as a collection of stars. Snowflake and hence is called a galaxy schema. Snowflake and hence it is called a galaxy schema or fact constellation. The main disadvantage of fact constellation schema is its more complicated design. Thank you.